A pleasant greetings to everyone, and thank you for giving us the opportunity to present our project today. My name is Ken Cydric C. Artificio, and I am here today with my group members.
I am Jeff Andrew Sarge.
Hannah Beatriz M. Marquez,
Carlene M. Manzanilla.
Mary May Vergara.
Today, we will be presenting the progress of our prototype for a pressure-powered generator. Our project is focused on harnessing mechanical energy from applied pressure to generate electrical power. This concept, though simple in theory, presented several challenges as we work to develop a functional prototype. The goal of our project is to create an efficient and scalable pressure-powered generator that can potentially be used in a variety of applications, from renewable energy system to small-scale portable devices. From our initial brainstorming sessions to building the prototype, we have faced both successes and struggles. We started by researching various energy conversion methods, which led us to choose a mechanism that could convert pressure into mechanical energy and subsequently into electricity. Through several iteration and prototyping stages, we have successfully built a working model, but not without encountering challenges along the way. Despite the technical difficulties, our previous meetings have been productive, and we have worked well together as a team to troubleshoot and refine our design. We have learned a lot about the importance of collaboration, testing, and adapting to unforeseen obstacles. We're excited to share with you our progress and the challenges we have overcome, and we look forward to your feedback and suggestions for our future improvements.
Hello everyone, I am Jeff Andrew Sarge from STEM 2, and today I will discuss the process of making our model. The first step in our project was gathering all the necessary materials. We worked with stainless steel, various metals, and other components that would form the base of our model. Choosing the right materials was important to ensure durability and functionality. We also needed to prepare and organize all our tools before starting, so we wouldn't waste time during the project. The tools we used included a grinder for shaping the metal, a buffing machine for smoothing surfaces, and an electric drill to create precise holes for assembly. Once the materials and tools were ready, we followed our design plan carefully. The design was crucial to guide the entire process and ensure our model would fit together correctly. The first thing we did was cut the steel into the desired shapes using the grinder. This was an important step as the cut had to be precise in order for the pieces to align during assembly. After the cutting was complete, we used the buffing machine to smooth the edges of the steel. This not only made the model safer to handle but also gave it a more polished and good appearance. We took care to avoid damaging the material while buffing, ensuring the surface stayed smooth and even. The next step was drilling the required holes. The electric drill helped us create precise holes in the metals to allow for easy assembly of the pieces. We had to make sure the holes were positioned correctly to avoid mistakes during the final assembly. At every stage, we paid close attention to detail. We wanted to make sure that all the parts fit together perfectly. After all the pieces were cut, smooth, and drilled, we assembled the model. We reviewed our work to ensure the prototype was both functional and well-designed once completed. This project was a great learning experience as it taught us the importance of precision, patience, and teamwork. We are proud of the final result, and we feel that the model not only meets the requirements but also demonstrates our hard work and skills.
Hello everyone, my name is Hannah Beatriz M. Marquez. We envision our prototype as a solution for sustainable and clean renewable energy. And we also come up with this idea because the energy has been rising over time. So we need energy-saving technologies. Before making the physical prototype, we plan it using blueprint. In the making, we use scrap stainless steel for the base. In the next meeting, we plan to add the components of piezoelectric and the other materials that will store the energy. And we will also add the one that will put pressure in the piezoelectric to make electricity. However, as we progress, it's important to note that our team is in trial and error. We cannot guarantee that the result of our model will be exactly the same, even we have our blueprint as a reference. Despite with these uncertainties, this journey and process enable us to improve our prototype.
Hi everyone, my name is Carlin L. Manzanilla. C-clamp is a tool used to hold objects together, often temporarily and non-destructively. Flap discs are used for grinding, blending, and finishing, as well as removing dust, paint, and weld seams. One of the primary advantages of flap discs is that they provide a consistent finish without gouging the surface. This makes them ideal for contouring and smoothing surfaces. Scriber is a hand tool used in a metalwork to mark lines on workpieces prior to machining. The process of using a scriber is called scribing and is just part of the process of marking out. Caliper is a measuring instrument that is used to determine the depth, length, and area of objects. File is a hand tool primarily used for smoothing and sharpening other tools, and for fine finishing wood. Sandpaper. Workers use sandpaper to smooth wooden surfaces. And sandpaper is also useful for removing loose paint, grit, or dirt when you're painting or finishing something. Stainless steel is used in carpentry for many reasons, including its durability, corrosion resistance, and aesthetic appeal. Cutting discs are used for cutting through various types of metals and other dense building materials such as metals and plastics for fast and straight cuts. Escuela is to provide accurate angles and straight lines for projects. Squaras are tools used for marking and referencing 90-degree angles and are commonly used in construction, woodworking, metalworking, and technical drawing. Buffing disc. The primary purpose of buffing is to enhance the aesthetic appeal of surfaces, unveiling a smooth reflective finish that brings out the inherent beauty of the material. Additionally, buffing also creates a protective layer, increasing durability and resistance to further damage. These are the machines that we have used. Electric drill. The purpose of an electric drill is to make holes or drive fasteners into materials like wood, metal, or plastic. Grinder. Grinder has multiple purposes including cutting, grinding, and polishing materials. Speed cutter. The purpose of a speed cutter is to cut materials quickly, such as metal, wood, plastic, and soft metals. Speed cutters are also known as chop saws or cut-off machines. TIG welding, used in many industries such as aviation and aerospace and sheet metal industries when welding, particularly thin materials and special materials such as titanium. Buffing machine. The purpose of a buffing machine, also known as a polishing machine, is to polish, brush, and buff a variety of materials and surfaces.
I'm Mary May Vergara and I'm here to inform everyone on their progress in our project. As a result, we did our project using critical thinking and teamwork, which are essential for its effective completion. We also need parental guidance in order to prevent incidents. Additionally, because it is challenging and demands precise attention to each part of our prototype, we need enough strength to make it. To safeguard the safety of our group members, we only want people who are capable of creating every detail of our prototype. Everyone contributes in their own way to achieve unity within the group. The team supported and assisted one another to make the work easier. We scheduled tasks for each day since every detail required several hours to complete. By the time of our project was finished, our group felt satisfied because the result of matched our expectations.
In conclusion, the development of our pressure-powered generator prototype has been both a rewarding and challenging journey. As a team, we have successfully built a functional prototype that demonstrates the potential of harnessing pressure for energy generation. We encountered obstacles, particularly related to optimizing the efficiency of energy conversion, but through teamwork and persistence, we have been able to address many of these issues. Our previous meetings were incredibly beneficial as they allowed us to align our ideas, discuss problems, and explore solutions. We are proud of the progress we have made so far, and while there are still areas for improvement, we are confident that we are on the right path. We believe that our prototype holds promise and could serve as a stepping stone toward developing more efficient and accessible energy solutions. Thank you again for your time, and now we are open to any suggestions you may have.
Thank you for allotting time to listen.